All right, we're finally going to give cosine a chance, and we're going to draw a graph of cosine, but I'm going to change it a little bit. So this time, let's graph y equals 3 cosine of x. This 3 is going to make a little bit of a difference in how this looks, but the way we're going to construct cosine is a lot like the way we constructed sine already. Let's see if we can review how to do this. We're going to start with our axes. Of course, we have our x-axis here horizontally, our y-axis here vertically. We should label those. Should be clear, this x is part of the cosine function. All right, and so I want to graph this function, 3 cosine of x, and let's do 2 periods again. So we want to go all the way to the end and mark the location where 2 periods would be done, which was 4 pi. We saw that last time with sine. And we're going to do the cut things in half trick again to get all of our special places, or at least enough of them to be able to grasp 3 cosine of x. So let's cut this length from 0 to 4 pi in half. And of course, that would make it 2 pi, halfway between 0 and 4 pi. I'm going to cut each of the pieces we have from that left over in half. So halfway between 0 and 2 pi, we have 1 pi. I'll just call it pi. Halfway between 2 pi and 4 pi, we have 3 pi. And we'll do one more round of cutting things in half. So halfway between 0 and pi, we have pi over 2. So now we can just count by halves, right? Pi over 2, 2 pi over 2 is pi. Next would be 3 pi over 2. 4 pi over 2 is 2 pi. Then 5 pi over 2. 6 pi over 2, which is 3 pi. 7 pi over 2. And 8 pi over 2 is 4 pi. All right, so that will get us through 2 full periods, knowing that the period of cosine is 2 pi. And so 2 times 2 pi is 4 pi. So we have from 0 to 4 pi and several special places marked, but we haven't done anything fancy to get all these fractions. All we've been doing is cutting all the lengths in half, starting with the 0 to 4 pi full length we knew we wanted. The y-axis is going to hold the, highest and lowest places that we're going to graph. So let's revisit how cosine works. The cosine of 0, visualize the unit circle. If it helps, draw a little one, just to get these basics down to get us going. We want to know what the cosine is at 0. Okay, well, when our arc length is 0, we're over here, the cosine is 1. That would normally start up here, but here's where this function's different. This 3 in front of the cosine means I'm going to multiply whatever my cosine value is by 3. So if the cosine of 0 is 1, I'm going to multiply that by 3 to get an output of positive 3. So this time, when x is 0, when my arc length is 0, the cosine value of it's going to be 3. Because though it's normally 1 on the unit circle, we're multiplying it now by 3. Everything else is going to work the same. Pi over 2, we're going to hit 0. At pi, the cosine value is normally over here at negative 1, but we're going to be multiplying that by 3, so we'll make it negative 3. So when x, our arc length is pi, our output of cosine is negative 1. Now, this cycle will continue because back up at 3 pi over 2, again, cosine down here would be 0. And you can start to see the pattern. At 2 pi, we're back up where we started here at 3. And then the pattern just continues cycling through all of these common places. But each time we're stretching all the way up to 3 and all the way down to negative 3 because of this coefficient in front of our cosine function, which does just that. We're multiplying all of our usual cosine values by 3. So if I connect these with a smooth curve as best I can, again, hand drawing these is not always easy, but they should be smooth. They shouldn't be jagged mountains. Do your best to draw them as smooth waves. We now get the graph of 3 cosine of x. It's just like the graph of cosine of x, except that graph would be a little different. So what we're going to start to see on these is that there are ways to adjust these graphs. I'm going to see if I can show you a layer on top of this now of what the plain cosine graph would have looked like. So if I wanted a graph, I'll just throw this on here, y equals plain old cosine of x. All right, so it would have the same places on the axes. I don't have to redraw those. And in fact, it would have the same high and low points and even x-intercepts. So at 0, plain old cosine is 1. So we'd have a point up here. At pi over 2, it's 0. At pi, it's -1, so it'd be right in here. 3 pi over 2, it's 0. At 2 pi, we're back up to 1. You can kind of get the pattern now. You just keep cycling back down through these to match the pattern. If I were to connect these graphs to get the plain old cosine graph, you'll see a lot of similarity between these two graphs. The pink one, of course, the bigger one I drew first, goes all the way up to 3 and all the way down to -3 down here. But then the plain old function cosine of x doesn't quite make it up to 3 and down to -3. It's just a little bit shorter or more squeezed vertically. It goes up to 1 and down to -1 and has the same x-intercepts, but just not as drastically high or low. So it turns out that these plain functions, the one I have drawn here in the cosine function, with no adjustments or no other numbers in front of it or anything, just the plain old cosine of x is what we could call the parent function. And then if you adjust it by putting something else with it, such as this 3 coefficient we added in front of this pink graph, that's a way you can change or alter or transform the parent function. So you might recall some of this from algebra class where you did this with basic functions such as x squared, x cubed, maybe a square root of x. Those basic algebraic functions were typically discussed with transformations, and those just change the way the graphs look. Well, it turns out you can do the same thing with parent functions. So the plain old sine of x, which we graphed earlier, and then plain old cosine of x, which is here in gray, those are the parent functions. This pink 3 cosine of x is an example of a transformed function. This one would be stretched vertically. And we're going to explore all kinds of ways to do transformations with these trig functions going forward.